robot starts upright as a quadruped and stays upright as it locomotes towards the object, okay? So our ultimate goal in this 8th line of evidence is evolve a quadrupedal walker, okay? So we start with a quadrupedal walker and we end the evolutionary process with a quadrupedal walker. In the second experimental regime, we start with a quadruped, but it's in a prone posture. So its belly is resting on the ground and its legs are horizontal. We evolve this system until it's able to locomote towards the object. When it gets there, we pause the evolutionary process and change the developmental program. And the developmental program for this robot, as you'll see in this third video, it starts prone, and then externally we gradually angle the legs downward so that it ends its lifetime, if you like. It only lives for about 5 seconds, okay? It ends as a quadruped. It starts in a prone posture and ends in this vertical position. So it suddenly is now experiencing a different developmental regime compared to this system. Okay, so we evolve here, pause, change the developmental program, re-evolve the solutions until we have a walker again that can get to the object. Once it gets there, we move into a third phase where we start with a splayed posture. So the legs are downward by 45 degrees and it has to transition to upright walking. Once it gets close enough to the object, we pause and then move on to the fourth phase of the evolutionary process, which is, like in the first regime, it starts upright and ends upright, okay? So in this experiment, we start and end with basically the end goal. We have a fixed body plan. Here, the body plan changes over evolutionary time, where change in body plan now is simply the deflection of the legs, okay? Within that, we actually change developmental trajectory, and we have these 4 sequential processes. It turns out that in the second experimental regime, we can realize upright quadrupedal locomotion faster and more consistently than in this regime. Okay? So for a roboticist, this is a somewhat anti-intuitive result. We have a more complex algorithm here, there's more sequential steps, but we can get to the end goal of this upright locomotion faster and more consistently. Okay, so just a little bit more details about our object manipulation task here. Here are just some snapshots from the video that you saw. As I mentioned, we can select for grasping, or just lifting, or just active perception, or combinations of 2, or combinations of all 3. Okay? The ultimate goal is to evolve something that can manipulate these 6 different objects. So we have 2 spheres, 2 cylinders, and 2 cubes. It's hard to see in these pictures, but they're of different size, the 2 objects. Okay? So in active categorical perception, the robot needs to distinguish between shape, but classify or group together objects of different size. Okay? The way that we select for active categorical perception is that as the robot is acting and manipulating an object, there are hidden neurons in the neural network. So I haven't talked about the details of the neural network here. We're using a continuous time recurrent neural network, or CTRNN. Was developed by Randall Beer. It has its own internal dynamics. We watch over time the signature of a couple of hidden neurons, okay, and then select for how those activations change over time. So if the robot grasps spheres of different size and the activation in the hidden neurons is similar between those, but if it grasps a cylinder and the signature of the hidden neurons is different from the signature you saw when it grasped the 2 spheres, that's good. It's starting to distinguish between these objects. Again, I wouldn't argue that it's developing a representation of these objects, but it acts differently in the presence of differently shaped objects, but it acts similarly in the presence of differently sized objects. Okay? Okay, here's some results. I'll show you how to interpret these. You'll notice that there are 7 panels. Above each one is a title that indicates which of the behaviors we were interested in did we select for. Okay, so in this regime, we performed 50 runs where the body plan was fixed, which is the gray, and 50 runs in which the body plan is evolving. And I'll mention that in a moment. Here we only selected for grasping. Here we only selected for active categorical perception. Here we only selected for lifting. Here, active perception and lifting, grasping and lifting, grasping and active perception, and the last one we selected for all three. Okay. In each panel, the horizontal time is evolutionary time, which again was about 8 hours. Okay, and vertical axis is ability. So you'll see 1, 2, 3, 4, 5.